Hello all. So you'll actually get to see me for once, put a face to the name. I'm doing a video recording of this form for a couple reasons. One, to just try something different, but more importantly, because the free software that I was using, the free trial period ran out, and I wasn't willing to buy it because it's $400, and I wasn't willing to steal it. So we're going back to the Stone Age. It shouldn't be too much different from what I do already. I'll just be using a blackboard instead. That software was unfortunately limited in the sorts of things I could do. So in any case, we're here finishing up week 5. So this is the 5th lecture of week 5 and just about the last piece of formal content that we'll cover. So I'm just going to run through the paper by Searle, is the brain's mind a computer program? That's the paper. So I'll kind of motivate why we're reading this at all, and then just begin. So the reason why we're reading this is because this is kind of along the trend of philosophy of mind that we were already dealing with. It's a little bit different approach. It's dealing with AI as well, artificial intelligence, which might be of interest to people that Virginia Tech has people that do computer stuff, right? Trying to make it relevant. And it's also a recurrence of the sort of early debates we saw in Descartes. So in philosophy of mind, it's still a live debate as to whether the brain is just the mind, or if the mind and the brain, the physical matter of the brain, is distinct from whatever the mind is. So although very few people are like radical substance dualists like Descartes, there are still people that say the brain is not the mind. The mind cannot fully be accounted for in terms of just referring to the brain or brain states or parts of the brain or anything like that. So, and this is a fun paper. It has a memorable thought experiment. So for all those reasons, we're doing it. So the first thing that Searle does is he asks, can a machine think? So, yeah. Oh man. And I don't need to write the title down because you already know what we're doing. So this question is very briefly dismissed. Can a machine think? He just basically says, well, of course it can, insofar as we think of a human body as a sort of machine of a certain form. It's going to be trivially true that it can think. So the modern worldview is that the body is just a certain sort of complex system, very, very complex system, but nonetheless a physical system, so you might think of it as a machine. And so insofar as we think of bodies as machines, it's pretty evident that bodies are capable of thinking. For some reason or another, somehow minds come out of brains. That's the general thought. So the more interesting question, he thinks, is it possible that a computer program or any sort of program can induce thinking? So that's the question we're going to address. So if you can't read that, that's reasonably legible. Can a program induce thinking? So that's the question now. And ultimately, he's going to say no. So if you're to characterize the thesis of this paper, it would be something roughly along the lines of, it is not the case that a computer program can induce thinking, or strong artificial intelligence is false. something along those lines. That's probably the easiest way to characterize it. One thing that might be useful to note is that for Searle, a program just means the manipulation of symbols. So whenever he's talking about a program, that is too small. It's just the manipulation of symbols. And sorry, my limited little laptop camera can't do any better video work than this. So, in any case, right. So now that we have that basic understanding, Searle introduces this famous test, and the famous test is the Turing test. So some of you hopefully are somewhat familiar with this. I'm going to spell it because I'm writing so slowly. Turing test. So, Turing test is a test of artificial intelligence, and the basic test is if a machine, or if anything can do the functions, the abilities of a certain other thing, it has those properties. So that's a very general way of doing it, of defining this question, so I'll be a little bit more precise. So another way to think about it is if a computer can perform in such a way that an expert cannot distinguish it from the performance of a human, it has that ability. So if, for example, a computer can play chess as well as a person would be able to play chess, then for all intents and purposes, we can say that the computer has the ability to play chess. It can play chess. So the same thing might go for being able to understand a foreign language or something. If it can perform a foreign language as well as anyone else, as well as any person, or indistinguishably well, then it has the ability to speak that language. And so a more general result of this kind of test is if a computer behaves indistinguishably from a person, we can say that it has a mind. So the kind of underlying assumption operating throughout this sort of Turing test is that all there is to a ability is the sort of functional aspect, the actual behavior associated with doing that thing. So all there is to being able to play chess is the actual physical movement of parts or something like that, right? Like, you can't say that you know how to play chess unless you've ever actually physically moved around the parts. So someone that thinks this Turing test is a reliable way to go about understanding AI would say that if a computer can pass the Turing test in terms of being indistinguishable in conversation or something like that from a person, then the computer literally has a mind. And for all the same sorts of reason that we can say you or I have a mind because we behave like it. That's really the only way that you know that anyone else that you ever speak to has any sort of consciousness, right? It's just because they behave in certain sorts of ways that seem as if they do. So one way that, or the way that Searle presents this thesis of strong AI, which is a product of the Turing test thought is that strong AI, he says thinking is merely the manipulation of symbols. He says formal symbols, but I don't know what adding formal has to offer. Thinking is merely the manipulation of symbols. That, once again, is hard to read. But I guess a lot of professors don't even use any sort of PowerPoint, so this is just an added icing. If you're already listening, it just helps. You can fill in the blanks. And surprisingly, this marker's holding out. I got a couple of markers because I always expect them to fail. So far so good. Right. So all there is to thinking is just this manipulation of symbols. So I think on one hand, if you think about this claim, it's a little bit strong, right? So we don't think that's what thinking is fully constituted by. Having just read What It's Like to Be a Bat, you might think that even if you could fully formally define something in terms of symbols or something like that, there would still be more to the puzzle. There's something above and beyond just any sort of manipulation of symbols. And I would say to a certain extent, actually probably fully, Searle is on board with that thought. So I guess that's just something to keep in mind also. He thinks this is far too strong. I think one objection that you could reasonably have is that this seems to be a weak formulation of strong AI. I think few people are really going to want to attach their names to something like, yeah, like all there is to thinking is just a manipulation of symbols. Like whoever thought that, I don't know. It's not like, one thing that you should do if you're going to attack a position is cite cases of that position occurring. And he sort of does that later in the paper with the Churchlands, but doesn't seem like anybody might actually hold that position. So that could be something you object to, but you have to elaborate beyond what I said, of course. So as a contrast to strong AI, Searle introduces weak artificial intelligence as a distinct sort of hypothesis about the role of artificial intelligence in understanding the mind. So I'm going to have to start erasing stuff up here. I had to write so large. So the question, yeah. So weak AI programs are useful models to understand the mind. So here, you know what I could do? I could pull the entire table a little bit closer. See if that helps. Such a heavy table. In this big seminar room, and I have a massive table. So the alternative hypothesis is weak AI. So this would maintain that minds and computers are never going to be the same sorts of things, or that computers can never produce minds, but that in certain limited capacities, using a computer model to simulate brain-like behavior will just be useful for us to understand the real thing, but it will never be the real thing itself. So this will be a sort of example that I point to repeatedly, but you might think like modern science, we can run models of what it would be like to digest a pizza or something like that, right? Like how all the enzymes behave and interact with carbohydrates and the fats or whatever. And we can run computer simulations of that and do iterations of it to sort of understand what sort of results would occur. But no one is going to say that because you've ran this simulation, you've in fact digested pizza. You'd only say this is a simulation of what it would be like if a stomach were to in fact digest pizza. So that's the kind of contrary position. So the refutation of strong AI. So this paper is against strong AI, right? So the basic refutation, and I'll just sort of draw the picture as opposed to write it all out, because it's a pretty intuitive idea and you can reconstruct the argument from that. So the idea is that there's a man in a room, right? Maybe this one's alive. Yeah, that's alright. And he receives various inputs, right? And I would butcher Chinese characters so they wouldn't even be intelligible, but just, it's all squiggles to us. So on the one hand, or speak for myself, to me, and to Searle apparently. So he gets this one input, right? And then he has an almanac, and in that almanac, it's a giant, thick book, huge, got endless pages of text. He can look up what he should do, standing on the book too, when he gets these sorts of symbols. So there's some page of this book that says when you get leftward facing squigglies or whatever, you should do some other sort of output. So he gets this one set of symbols, and then on the other end he outputs, say it's rightward facing squigglies, and that's the appropriate response. And so this sort of Chinese room is supposed to emulate a program. So what's going on here is this is just the manipulation of symbols. So there's just some formal system, and it has a fully comprehensive set of rules by which there's some specific output for every specific input, right? And it can be infinitely complex, but the only significant point is that there's always an answer. And all the Chinese room guy does is he provides those outputs given the inputs, and he follows a specific set of rules. So unbeknownst to him, all of these symbols are in Chinese, or maybe they're in some alien language in my case. But at the end of the day, would we say that he knows Chinese or he knows that alien language? No. So the intuition that's supposed to be drawn from this case is that clearly him manipulating any sort of symbols or something like that is not going to be sufficient to constitute knowledge, because, or knowledge of that language or thinking of that in that language, because the sort of the rules, the syntax as he calls it sometimes, the formal construction of these operations is not sufficient to give us any sort of content or semantics, any meaning to the symbols. So the symbols don't have meaning just in their being manipulated in certain sorts of ways. They only get meaning through our sort of understanding. And of course, computer programs don't have any meaning attached to the sorts of symbols that they use, ones and zeros. It's just all a set of rules, a certain sort of syntax that dictates which outputs are given in which sort of sequence. So just like the man in the Chinese room wouldn't know Chinese, a computer wouldn't know Spanish or something like that, or wouldn't be thinking just because it can give these outputs in a certain sort of sequence. So that's the thought. Yeah. So the other important point of this is that not only is the reputation of strong AI, but as I already pointed out, strong AI and the Turing Test are closely related. So it's also going to be a certain sort of reputation of the veracity of the Turing Test, right? So it seems like the Turing Test isn't a good test for whether or not we should think computers are capable of thought, insofar as this guy in this room might perfectly pass the test for being able to do Chinese, right? He's fully functionally capable, but even if he has an indistinguishable ability, that indistinguishable ability isn't the same thing as having Chinese thoughts or having a certain sort of knowledge of the Chinese language. So there's this sort of disconnect. And then from this sort of result, Searle derives a series of axioms, and they're just kind of premises to formalize the argument, and then some conclusions. So I'll cover these axioms. They're really, don't think of anything special in terms of these axioms. They're seriously just premises. Axioms are supposed to be incontestable basic starting points for any sort of argument. And I don't think these are quite that strong. I don't think people are just like, yes, this is incontroversial claim. But so the first sort of axiom that he has is that computer programs manipulate formal symbols or just symbols. And I don't think this is too controversial, at least the way we conceive of I wish I had better pens. At least the way we conceive of computer programs these days, it seems like every computer program that we've come across so far is just in one way or another manipulating various like content-free symbols, primarily ones and zeros, but in any case, nothing that has specific content ascribed to that. So another case, if this is at all useful to think about in this way, you can think about like logic, right? So when we did those sort of valid argument forms, this is sort of this argument form, right, as we all know at this point, is valid, modus ponens, and the issue is not a matter of content, it's not a matter of semantics, it's a syntactical issue, it's a matter of the structure of the argument that allows it to be valid. So you could fill in anything you want, and that's sometimes a tricky way to get people, is, you know, you say all squibbles are squabbles, or if all squibbles are squabbles, then all wobbles are tobbles. All squibbles are squabbles, so therefore all wobbles are tobbles. And people are like, no, that can't be valid, that's crazy. But the point is, it doesn't matter what the content is, it's just the formal structure of the syntax. So the same thing might apply for computer programs. It doesn't matter what they're sort of processing, just as long as the sort of structural relationships maintain in the same way. The next general point is that, and this is also supposed to be pretty uncontroversial, although not everyone would agree, human minds have content. So, differently from a computer program, when we think in terms of specific sort of meaningfully laden concepts, right? Like you have associations, you think of things when words are said. When we do the if P then Q thing, we oftentimes fill it in with real sentences to sort of check to see if it makes sense. And so there's supposed to be this strong disconnect between computer programs on the one hand and human minds on the other hand, such that a computer program is, in an important sense, nothing like a human mind. Because while one is completely formal and about syntactical relationships, human minds have this additional layer of content. You might even think about it as what its likeness, right? If you're still on the Nagel trip, certain sort of specific feeling and that sort of thing. And there's nothing entailed in a computer program that would make us assume that there's the same sort of thing going on in the case of a program. So, right. So, in a basic way, I guess a result of these two together is just that syntax does not equal semantics. So no matter how much formal structure or organization you get, you're never going to get a case in which this arrangement, this P's and Q's and ones and zeros or triangles or whatever, is going to mean something to you unless you already have that meaning kind of associated with it. Yeah, and so you might even just say this is its way of saying 3. So syntax is not constitutive nor sufficient for semantics. So no matter how much syntax you have, no matter how much formal organization, say you construct a really long logical argument with a bunch of if P's and Q's or various other disjunctions and conjunctions and whatever, no matter how complex that's going to be, at the end of the day, you're still not going to fill in the meaning of those P's and Q's just by adding more syntactical complexity. So it seems like syntactical complexity in itself is insufficient to have any sort of mental content. So this has important implications for, sometimes people will say, well, computers can't think now, but that's just because they lack the processing power. Maybe someday in the future, when they get really sophisticated, they'll be able to think. And it seems like, in principle, Searle is going to object to that on the grounds that it doesn't matter how many ones and zeros you add. Those ones and zeros can't ever add up to make something of an entirely different kind. And that thing of a different kind is like mental content. It's semantic. And there's no way to bridge the gap between syntax and semantics by just doing more syntax. Yeah. So the obvious result, and this almost trivially follows, is that programs aren't sufficient phrase it exactly. For minds, yeah, that's easy enough. Programs aren't sufficient for minds, and that just seems to clearly follow from the fact that computer programs are completely formal, human minds have content, and there's this unbridgeable gap. So this is the explicit step that needs to be taken. So syntax goes to 1, semantics goes to 2, and then there's an irreducible difference, so one can't be reduced to the other. And that's just a formalization of the thought experiment that was already drawn out. But that's just kind of a vivid way for you to understand what he thinks is the truth of his claims. The thought experiment, that is. So, antivirus. So one of the sort of caveats, he makes this as a conclusion, but it doesn't really follow from what he said. It's more of a caveat, really, is that he hasn't said that only biological systems can think at this point. Um, so he's not committed to the claim that it's only like physical matter, meat of a certain specific type that's capable of thinking. Just that something that is only composed of, it's only a matter of running syntax and by certain rules isn't going to get you there. So you'll need something more. So if it were possible that computers could have semantic content somehow, then he might change the story a little bit and be like, yes, computers do have minds in a certain sense because they're manipulating not just syntax, but there's some content, there's some meaning behind the terms. But the thing that he is trying to show is that it's clearly false that thinking just is the manipulation of symbols. Clearly, you can manipulate symbols all day, and that doesn't mean you know anything about what's going on or that you have thoughts at all. So I've never had a Chinese thought, even if I could pass one Chinese card to somebody else with a different Chinese card, and there would be a conversation going on, and I'd be the intermediary, and these symbols have meanings attached to them. But as long as I don't know those meanings, like how would I ever know Chinese? So this last part of the paper is dedicated to him considering some objections. So it seems like there's some interesting objections. Yeah. So one of those objections is that, and I'll just talk through this stuff because the writing, these pens are dying gradually, and I think these are intuitive objections. If you want to write on this, you can pay closer attention as time goes on. So the first objection is that parallel processing could do a better job. That the difference between a mind and computer program is that computer programs run linearly, right? It's just like a sequence of ones and zeros. There's not multiple operations going on simultaneously, whereas minds are simultaneously computing innumerable things, and somehow this difference will result in a sort of qualitative difference. So maybe once we get awesome computers that can, process 50 things at once or something like that, then we'll have minds. And he just sort of reiterates the previous point, namely that it doesn't matter how complex you're going to make this manipulation of symbols. Insofar as it continues to be a manipulation of symbols, it's never going to get you mental content. And that's just a basic kind of premise that he's committed to. And so this might seem intuitively plausible because you think of a case of, he takes the case of a Chinese gym is what it is, and it's a bunch of people coming together and they all work on the same sorts of, they're passing around symbols in various ways, and maybe this would allow for a mind. And so that seems strange, like what is going on? But think about the brain, right? At the end of the day, what's going on in the brain? In a certain way, there's just all sorts of neurons interacting. They're just passing energy and chemicals in various ways, very complicated ways. But it doesn't seem like any of those neurons or whatever have any idea of what's going on, right? It's not like they have any mental content associated with the little electrical charges or chemical pathways that are being activated or passed back and forth. But even if there's no content associated with those charges or whatever, it seems like somehow consciousness arises, right? So if enough guys got into a room, a giant Chinese gym, or say the entire country of China, right? You have 1 point whatever billion people all working together and passing symbols around. Then somehow consciousness would emerge out of that. And that sounds crazy, I agree, but that seems to be what's going on in the case of our mental states, right? It's just you get some billions of neurons together and I'll have them cooperate, just passing back and forth various physical things that they have no understanding of, and here we are. So that's the mystery. So as much as Searle thinks that this sounds crazy, it seems to be the case nonetheless. There's another paper that was written on the subject, and the person came up with they used China, and I think they called it the Chinese demon or something like that. So the idea is that you get these billion people together, and then they all pass around symbols, and then a demon emerges out of it that's like a supermind. And it's like, oh, this is a crazy thought experiment, silly philosophers. And it's like, well, that's our best story of what's going on with consciousness, right? So it's, it doesn't seem obvious, but it seems nonetheless somehow that even this manipulation of contentless stuff like electrical charges or whatever, or formal symbols, somehow out of this emerges consciousness. So the reason that Chalmers maintains that there's this undividable or the unbridgeable gap is because of the brain's specificity. So he says that the specific sort of materials and chemicals that constitute the brain are what allow for consciousness. And unless whatever other machine or entity has those similar sort of powers and capacities with the specific sort of physical makeup, it's not going to be able to produce a mind out of that. And so this is the case where the pizza sort of the pizza digestion occurs. So you wouldn't think that a computer can actually digest a pizza. It can only model it, because all it has is these sort of a single type of thing, and that's just computer program with ones and zeros or whatever. The reason why a stomach can digest those is because it has many different types of very specific enzymes and molecules interacting in all sorts of ways, and acids or whatever. And so that specificity is what allows for actual digestion, and it's that specificity, although different, that allows for actual consciousness. So, right, anything that has minds must have the causal powers similar to brains, right? So those physical constitution of a brain, and you're not going to get that causal capacity just by manipulating symbols in a certain sort of way. And you can make it a very complex manipulation of programmed molecules, but unless they have those powers, they're never going to be that. And so at the end of the day, Searle seems to think that symbol shuffling will never get you there, but there's still this mystery, and that's namely that it seems like somehow things that are just manipulating or just interacting and have no mental content do give rise to mental content. So yeah, that there's still a problem. And of course, a lot of people disagree with him, and they think that he gets the whole problem wrong. So if you're interested in that, you can ask me, and I can send you more papers on this sort of stuff. But thank you for that, or for your time, and hopefully this format wasn't too burdensome. This is a fairly long lecture, but you're free from further reading. So thank you, and I'll see you next time.